This problem is pretty straightforward. The way I look at it is a good workout in trigonometry. So we have two angles, and you see the word exact, you see the expression exact value there. So we're going to keep stuff exact values, no calculators in this one. But I'm going to show you something about this with the calculator. So there are two angles. Sine alpha is 3/5, and alpha is in quadrant 2. And cosine beta is 12/13, and beta is in quadrant 4. And we're asked to find cosine of alpha plus beta. The sum formula for cosine involves all four of sine, cosine of both alpha and beta, right? It's cosine alpha, cosine beta minus sine alpha, sine beta. Now, you might need to draw triangles, but these are famous triangles. This is the 3, 4, 5 triangle. And, well, we'll draw it. So let's first ignore the signs, the negative signs, if there is any, and say, well, sine alpha equals 3/5 would happen in a triangle like this. Our good old friend Pythagoras will tell us the missing side is 4. And so cosine alpha is either 4/5 or negative 4/5. That's why this information is here. The fact that alpha is in the second quadrant means that the cosine is negative. So the two coordinates of this point is minus 4/5 and 3/5, right? That's cosine and sine by definition. But basically, what we have is, so cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So sine alpha was given to be 3/5. And we figured out that cosine alpha is negative 4/5. Now, if we draw a picture of a right triangle where cosine beta is 12/13, we're going to find the missing side. Cosine beta is 12/13. We're going to find the missing side to be 5. This is the 5, 12, 13 triangle. Therefore, sine beta is either 5/13 or its opposite. Which one? That's why this information is here. In the fourth quadrant, cosine is positive. Well, it was given to be positive, but sine is negative. So sine beta is negative 5/13. So cosine beta was given to be 12/13, and sine beta is given, sine beta, we found it to be negative 5/13. And no matter how bad the numbers are, the denominator will always behave kind of nicely. It's always going to be nice numbers and after rationalization. And it's always the same too. So what we have is the common denominator is 65. And we have negative 48 plus 15, which is negative 33/65. And that's the answer. And we got it right. There is something that I want to show you about this problem, because the way we're checking is not really something that you can do during an exam. And this one might be involved because whenever I'm putting this on an exam, you have to find other stuff, not just cosine alpha beta, 2 tangent of 2 beta, tangent of beta minus alpha, a whole lot of things. So there is one way to verify things with the calculator. If we enter inverse sine of 3/5 is the same as 0.6. We get 36.86, but that's not alpha, right? Alpha is in the second quadrant. This is 36 and change. What we have is the supplement of it. So I'm going to subtract it from 180 by multiplying by -1 and adding 180. And that's really alpha, 143 and change. So alpha is, this is just checking, the problem is over. 143.13. I'm going to store that in A. Alpha A makes sense. Okay. Just to check, recall A. Yeah. And then we're going to do the same thing for beta to have the actual angle in the calculator. So if we enter inverse cosine of 12/13, we're going to get the answer in the first quadrant. But that's not what we have, right? We don't have this 22. We have minus 22. So we're going to multiply this by -1, and that's the one that we're going to store in beta. Store in B. There we go. So now we can verify it using the calculator. We're going to find the cosine of, and now we're going to recall A. Yeah, this is a little unsettling, but this is A in there. Plus recall B, close the parenthesis. And that was just one parenthesis. So I'm going to push enter. And we got a negative number, and it's about -1/2, and 33 is about half of 65. But my favorite is to say, this number here, if I did everything right, this number here is -33/65. So if I want to wipe out that 65, I'm going to multiply this by 65. I should get that -33 back. And we do. That's kind of nice that approximations remain that precise. When I went to high school, we didn't have such smart calculators. My calculator would say something like -32.9999983. But it was still pretty close. But this one is sort of, you can hear the click. Yeah. So I thought I'll show you this too. Thank you for watching.